Good evening, ladies and gentlemen. The previous talk I gave was on the Type 21 U-boat. I'm now going to talk about the other side, the people that took on, well, I shouldn't say took on the Type 21 U-boat because it never went operational, but would have taken on the Type 21 U-boat, the development of the Atlantic Escort in the Second World War. What were the British doing between the wars? It's a popular misconception that the most efficient escort vessels were destroyers. Because we're in this august organisation, none of us have fallen for that, have we? That's a V&W destroyer, which was heavily used in the Battle of the Atlantic. They were first produced in World War I, but they were an older destroyer being used for escort duties in World War II. At the top, that's what they looked like originally. Actually, that's two versions of them as escort destroyers. Modified, the top one's been modified as an anti-aircraft escort, and the bottom one is an anti-submarine escort. Those figures in red, you'll have to memorise and pay attention to. I had to do some naval architecture in this talk because it was required. Now, why aren't destroyers good escorts? Defensively, they were escorting the battle fleet, but submarine attacks on the battle line became less and less common as the speed of the battle fleet got faster and faster. Because if you remember, in World War II, the maximum speed of a U-boat was about 8 knots, and the battle fleet's doing over 20 knots, so they can't catch them. Now, offensively, it required torpedoes and speed. That's what a destroyer does. But the latter speed is very expensive to get regarding space and weight. We all know that. And a destroyer's low angle guns are no use against aircraft. Ooh, that's all right. Torpedoes are no use against submarines. In those days they weren't. Speed was in excess of requirements. We all kind of know that you can't use sonar in World War II and probably today above 20 knots. So if a destroyer can do 36 knots, what's the point? And seaworthy was not as good as a sloop. Destroyers are not very seaworthy. We'll see that in a minute. Consequently, with a limited purse, the Admiralty commenced construction of a series of sloop classes. And they did quite a few. The Bridgewater class was when they started, and they looked pretty much like the drawing there. A couple of guns, long forecastle, series of classes, and you can see there under the Grimsby class, the Royal Australian Navy built 4. Ending up in 1939 building 2 ships of the Black Swan class, which we'll talk about in a minute. There's HMAS Yarra, very typical of these sloops. You can see a long forecastle, very robust hull, an open bridge, 3 4-inch guns. Down the back, the stern, as we like to call it, there's minesweeping gear and depth charge rails and depth charge throwers. We had 4 of those. Now, the Black Swan class, that's what I was going to talk about. That's what it looked like. And you can see a bit of a contrast there. It's got twin gun mounting, so it's got 6 4-inch guns compared with 3. Now, I should point out that the figures in red that I've blotched into there, that's because a lot of the information that you find in books and on the internet is not right. So all the way through this talk, you'll see that I've corrected things, and in some cases had to do naval architecture calculations. Who here knows what TPI stands for? I had to do that to work out things like the full load draft. And you can see those funny figures on the side then popping up again. They'll come in. So this is a very nice ship. It's quite big. It's bigger than those destroyers I just showed you. But it can only do 19 knots compared with 36 knots. Now, the Black Swans would prove to be the best escort vessels employed in the Atlantic. So those ones that they developed just before the war were the best escort vessels in the Atlantic, and indeed widely regarded as the Rolls-Royce of World War II convoy escorts by the US Naval Institute. Even the Americans thought they were good. Propulsion, twin screw, 2 Admiralty 3-drum water tube boilers. They've got turbine engines. They've got a director. My point. An Admiralty fire control clock for surface targets and a fuse keeping clock for aerial targets. Does anybody know why they're called a clock? In World War II, they called analog computers clocks. Well, the British did. So those are computers, but they're not electronic. They're mechanical analog computers. Type 127 Asdic, 2 depth charge rails, 4 depth charge throwers, 40 depth charges to start with. By the end of the war, they were carrying 180. Denny Brown active fin roll stabilizers, except they didn't work particularly well, probably because the control technology wasn't up to it, I suspect. And they cost £360,000 each. Sounds cheap today, doesn't it? But it was expensive in the day. Everybody remember this? Is Rawson and Tupper still used? Because we're going to talk a lot about seakeeping. Length to beam ratio has little influence on motions, although a lower LB ratios are preferable. I probably won't read all this out, but you can see it there. Length to draft ratio, high values lead to resonance. A high L/D ratio is more conducive to slamming. Block coefficient, generally the higher the block coefficient, the less the motions, and the greater the increase in resistance, but influence is small in both cases. Prismatic coefficient, the higher the CP value, the less the motion amplitudes, but the wetter the ship. High CP leads to less speed loss at high speed and greater speed loss at low speed. Wow. Water plane area forward, increasing this leads to increased vertical wave bending moment. Forward sections, U-shaped sections usually give less resistance in waves, and larger V-shaped sections usually produce lower amplitudes of heave and pitch and less vertical bow movement. Above water flare has little effect on motion amplitudes, but can reduce wetness. Freeboard, the greater the freeboard, the drier the ship. Remember all that? Come up later. There'll be a test. Now, compared with a destroyer, indeed with the destroyers that I showed you, the VW ones, they displaced 18% more, had a higher block coefficient, fair bit higher the day, was slightly shorter, had a significantly lower L/B ratio, had a slightly higher L/D ratio, and had a longer forecastle, and consequently had a much better seakeeping performance than that destroyer there. Good ships. Now, we all remember that in 1938, don't we? The Prime Minister, Chamberlain, came back with a piece of paper in his hand, peace in our time. Got Mr. Hitler's signature on it. Mr. Hitler wasn't going to do anything. Now, the Royal Navy is not convinced that it's peace in our time. By 1938, it was clear that there were too few escort vessels, both for ocean escort work and more urgently for the East Coast. The East Coast is where the English Channel is. Rearmament had started, but this made matters worse. The traditional builders of naval vessels and their engines, I mean, we're talking steam turbines here, were all working to capacity and beyond. So why didn't the Royal Navy just build more Black Swans if it was the best escort vessel for the Atlantic? The RN would have liked to just build more Black Swans, but turbine engined and fitted with all the requirements of warship construction, they could not be built in commercial yards, had to be built in the naval yard, rapidly enough or cheaply enough. This is where my advice to young naval architects is that better is not always better. So several options for cheap anti-submarine vessels were considered. Converting commercial trawlers. There's one, which they did convert. You can see some figures there, about 11 to 12 knots, coal burning. A single reciprocating engine, no turbines. Endurance about 3,500 miles at 9 knots. Moderate Asdic platforms, but inadequate subdivision because they're commercial vessels. Conversion would take about 4 weeks and cost £35,000, but they're too slow. An Admiralty trawler. These trawlers were built specifically for the Royal Navy. Similar sort of performance, also coal burning, but because they were built specifically for the Royal Navy, they did have good subdivision and they were good Asdic platforms. They take 4 months to build and cost about £57,000. So about 1/6 the cost of a Black Swan class frigate, but they're too slow. A converted whale catcher. Can't talk about them, but we'll have to, won't we? Converted whale catcher. They're faster because they're chasing whales, 16 knots, so that's good. Oil fuel, still with a reciprocating engine, good endurance. Moderate Asdic platform, subdivision bad because it's just a commercial vessel. Conversion would take 6 weeks and cost £75,000. And as I say, would you be happy with this freeboard in the middle of the Atlantic? Probably good for hauling whales into the side, but don't know what that one looks like yet, but a new whale catcher to Admiralty requirements. 900 standard, 16 knots, good speed, oil fuel, good endurance, good Asdic platform, adequate subdivision because we're designing it ourselves. 7 months to build and cost £90,000. Converting a minesweeper, because a Bangor class of minesweepers will convert them and make them anti-submarine escorts. Good speed, oil fuel. They've got turbines or diesels, which is going to be difficult for the commercial shipbuilders. Good Asdic platform, good subdivision because they're designed by us. 8 months to build and cost £135,000. Simplified Kingfisher. These were early corvettes, but they look like mini destroyers, and they were mini destroyers. Full naval kit, full naval standards. Geared turbines, 20 knot speed, good Asdic platform, good subdivision, 8 months to build and cost £160,000. Even more, Hunt class destroyer Escort. This is a real ship, 29 knots. Geared turbines again though. Good Asdic platform, good subdivision, 12 months to build and cost £400,000. So that's more expensive than a Black Swan. But those were the choices. Not too surprisingly, faced with these, they picked option 4, which was what? That was the new whale catcher to Admiralty requirements. So they got a design. And it makes sense that they would pick that one. Most of the others you could pretty well write off. So the Admiralty choice fell on a whale catcher design, partly because the design was already in existence, and partly because the overall length of 190 feet would make available a number of slips into smaller shipbuilding firms. 190 feet was critical. Get the maximum number of yards building them. Thus result in more rapid shipbuilding. Same time, the 4-cylinder triple expansion engine that they were going to be fitted with was an existing engine in commercial ships. Those shipyards knew how to build them, fit them, maintain them. Mind you, that's a lie, partly because the design was already in existence. Despite the fact that I've taken that out of a book, it wasn't in existence. Smith's Docks managing director, Mr. William Reid, had made an initial proposal based closely on the whale catcher Southern Pride, which we saw earlier, but it got it rejected. Even though it went through a few iterations, it got rejected by the naval constructors. Rejected due to poor subdivision and a bar keel. Had a bar keel, they didn't like it. Now, Reid then went back, same bloke, produced a new design that was accepted and became the Flower class corvette, which is that guy. So that's the first of the new Atlantic Escorts. About 1,160 tonnes full load, if you can believe my calculations. 190 feet, which is the critical number. Can do 16 knots. It's got the reciprocating engine. Complement of 85. Those numbers will be significant in a minute. It's got initially 2 Scotch tube fire tube boilers, which are not latest technology, but what commercial ships were using. Some of the later ships did get Admiralty 3-drum water tube boilers. It's got 1 4-cylinder triple expansion engine, which is easy to make and easy to run. No fire control system for the guns. It's got Type 123 Asdic, 2 depth charge rails, 2 depth charge throwers, about 25 depth charges, later increased. Bilge keels, but they were too narrow, weren't effective. They cost £90,000 each. So you could get 4 Flower class corvettes for the price of 1 Black Swan sloop. 26 were ordered on the 26th of July 1939, which was before the start of the Second World War. Just before the start of the Second World War. A corvette would roll on wet grass. We all know who Nicholas Monsrad is, don't we? We've all read The Cruel Sea. I hope. Was this fair or even true? Actually, I break this down into two things. I'm not sure I'm entirely right here with lecturers in the room, but sea keeping or sea kindliness and seaworthiness. Now, the flower class compared with a destroyer had a higher CB and CP and a lower L over B and L over D. Soon after the flowers entered service, there were complaints about their rolling. To considerable extent, these complaints were due to unfamiliarity with the way of a ship in the sea, Proverbs. Their seakeeping and rolling was no worse than any other ship of their size in the conditions in the Atlantic, which is true. The flowers were later fitted with deeper bilge keels, which reduced rolling. On the other hand, seaworthiness, the ability of a ship to survive at seas, the flower cast, they were remarkable little ships with a fantastic ability to keep going in weather in which other ships, such as destroyers, were unable to operate. They're not a bad design, because that's really what you want to have. So basically, they weren't comfortable, but by golly, they could survive anything, even in the Atlantic. And here's some examples of that. This bloke commanded escort groups in the Atlantic. Got into a storm. The convoy was hit rather badly by this gale. It was reduced to about 20 ships. I ordered the destroyers back to England. The two corvettes were much better suited to this weather than the destroyers and could still manoeuvre fairly easily. I've therefore sent them round to count how many children remained in the bed and to find out if the escort oiler was still with us. One corvette came back with a count of 20 and the other with 21. Just a little later, he says, we were ordered to Londonderry, which was the base for the escorts, and then to Androssen to dry dock. We had only left dock on the 12th of January, and it was only the 22nd. B5 group had been pretty well decimated by that gale. All 4 destroyers were weather damaged. The 3 older ones badly. Only the 2 corvettes were left. Good little ships. We need to know something about Asdic if we're going to talk about it. So this is Asdic type, the 120 series, which is what the corvettes have got. Range is about 1,500 to 2,000 yards at 15 knots in moderate sea conditions, which is all right because they can only go 16 knots and you hope the conditions are moderate. Range is reduced as the speed of the ship increases. Could not be used above 20 knots. Affected by sea conditions, water temperature, density and layers, which is still the case, isn't it? No indication of the depth of U-boat. Couldn't give you the depth. Contact lost the contact is lost at a range of 750 yards if the U-boat is deep and a range of about 150 yards if the U-boat was shallow. So as you're approaching the U-boat, it vanishes at those distances. The target bearing could be an error of up to 16 degrees. An experienced officer using a cumbersome cut-on procedure, they go backwards and forwards and backwards and forwards and try and narrow it down a bit, get it down to maybe plus or minus 5 degrees. Looks like that. Now, as I said there, you could actually calculate the depth of the U-boat because we're all engineers, aren't we? If you know the 2 things in red, the angle of the sound beam and the range, you can work out what the depth is, except for that error factor that's in purple, because that beam is 16 degrees wide. They're only guessing. But it's what they had. This is how it worked in a typical scenario. So there's the escort vessel approaching at 16 knots. In this example, this is typical. At 200 yards, the U-boat disappears. It sails on, drops its depth charges. Now, in that time, the U-boat could be anywhere inside that green circle. And those little circles are the effective range of the depth charge. The brown circle is lethal and the yellow circle could damage it. So as you can see, you've not got a great chance of, unless the U-boat doesn't do anything, just sits there and waits to be killed. So as you can see there, got to be within 20 feet to blow it up and 40 feet. Oh, good. Now, the first flowers are commissioned April to August 1940, and that's what the first ones look like, including having the mast in front of the bridge. Now, we move on in the war. New ships. Frigates. In fact, the first frigate designs were considered towards the end of 1940, when a review was made of the prospects of building vessels more suitable for service in the Atlantic. It's a bad place to be. And particularly, they were looking for higher speed. Higher speed was always a target, plus better seakeeping and greater range. But still, they needed to be able to be built in commercial shipyards, because all the naval shipyards were fully occupied. The River-class frigate, that's the one they came up with. Bit hard to see the diagram there, but as you can see, it looks a lot like that Black Swan sloop, except it hasn't got as many guns on it. Pretty big. Once again, I've had to correct some of the numbers. It's got 2 of those reciprocating engines, so they're not going for turbines because they still want to build them in commercial yards, but they've got 2 engines. They can now do 20 knots. It's got enough guns. It's also significantly got this new weapon. It's a head-throwing weapon called Hedgehog. We've got some more of those funny numbers there too. So it's twin screw propulsion. It's got 2 of those triple expansion engines. It's got water tube boilers rather than fire tube boilers, so they're more efficient. Still has no fire control system. It's got Type 271 radar now. Many were commissioned with HFDF at the mast. Who knows what that is? High frequency direction finding. You can direction find the radio transmissions of the U-boats. If they're stupid enough to transmit, which they have to transmit because they have to be told where the convoys are and tell them that they're going for them. It's got 2 depth charge rails and now 8 depth charge throwers, although they did reduce that later. Started with 100 depth charges and later 154. I'll talk about Hedgehog in a minute. They cost £240,000 each. Ooh. HMS Spey joined Western Approaches Command in June 1942. Now compared with, can't read that, what does it say? Compared with the destroyer, I hope. No, compared with a Corvette. Compared with the Flower-class Corvette. Displays 61% more, so it's a lot bigger. Had a higher block coefficient, significantly. 49% longer, which is going to help. Slightly higher LB ratio, significantly higher L over D ratio, and had a longer forecastle. Not too surprising, they had a much better seakeeping performance. I probably exaggerated it in the photographs. It's probably not too untypical. Improved Asdic, Type 144, began about May 1940. First sets entering service a little over a year later. It was designed to control those head-throwing weapons, which I will tell you about in a minute, such as Hedgehog. Could also direct a conventional depth charge attack. Electronics were redesigned to improve discrimination, more accurate, picking out a target from background noise. They put range and bearing recorders on the ships now, so different parts of the ship rather than just in the Asdic shack could see what was going on. There were repeaters on the bridge in the wheelhouse. These provided data on the course to be steered and the point at which the weapon was to be fired. Previously, they had to make that up. The slope of the trace gave the closing speed. The transducer changed automatically in 5-degree steps, so previously you had to manually move the Asdic. Now it does it itself. And that would decrease to 2.5 degrees as you got close to the target. The operator only had to select, I want to search to port or starboard. Makes things easier. There's that head-throwing weapon, Hedgehog, which is, as you can see, is just basically a rocket launcher, but it's launching depth bombs. First tests in February 41 at HMS Burnbeck. Sea trials followed in July 41 and September 1941. So, different sort of attack now. U-boat has no warning because you don't have to wait till you get over the top of it. And there's no dead period because you're firing before you lose the contact. And the projectiles don't explode unless they hit the U-boat. Because I probably didn't mention that before, but when depth charges went off, it disturbed the water enough so that you lost sonar contact. But this only goes off if you've got a hit, at which point you don't care. We had some in the Royal Australian Navy. That's HMAS Gascoyne, which is a British River-class frigate design. And we may recognise that bridge. I think we built 8. I could be guessing there. Quite a few. Now, the Flower class corvettes were upgraded. They started to look like that. They extended the forecastle aft, helped to get the deck dry, and created additional accommodation. They put the 271 radar on. They moved the mast from in front of the bridge to behind the bridge. Additional depth charge throwers and depth charges. They fitted Hedgehog, but you can't hardly see it, but it's there. And they gave them the Type 144 Asdic. So they're much better, more useful ships. I think I did that. Now, they'd started building these frigates, but some of the shipyards couldn't build the bigger ship. So they designed a new class of corvette called the Castle class that could be built in those shipyards that couldn't build the bigger ship. Once again, it was designed by that bloke, William Reed of Smith's Dock. He's a busy boy. As you can see, it's a bit bigger than Flower class, 1,580 tonnes, and it's 225 feet long compared with 190 feet long. They're commissioned with a new weapon, which I will talk about in a minute, a head-throwing weapon, Squid. There's more of those funny numbers. Now, compared with the Flower class, displaced 36% more, at a slightly lower block coefficient because they're longer and finer, 18% longer, in fact, slightly higher L over B ratio, had a slightly higher L over D ratio, had a longer forecastle, and not too surprising, there was an improvement in seakeeping performance, probably mostly due to the length, I would think, and the increase in displacement. Now, for naval architects, we're interested to note that they were actually a half a knot faster than the Flower class, despite displacing 36% more and having the same installed power, which is all down to the increase in length. Useful stuff, isn't it? There was in this ship the first limited amount of prefabrication of the structure. The wireless and radar officers were supplied complete and just put on the ship, as with the lattice masts. Propulsion, exactly the same as the Flower class corvette. Once again, no fire control system, commissioned with the 271 radar and the HFDF. They had Type 144 and Type 147B sword depth finding Asdic. Finally, work out what the depth of the U-boat is. And we'll talk about that in a minute. They only had a limited amount of depth charges because their main weapon was the Squid with 81 projectiles, cost £190,000 each. So that's £100,000 more than a Flower class. Hadley Castle was commissioned 18th September 1943. Squid, developed from the Fairlie 3-barrelled mortar. Those of us who are as old as I am will remember Limbo on board our DEs. Limbo was the successor anti-submarine mortar to Squid. We had them in the... It's a 3-barrel 12-inch mortar. It can be tilted 15 to 30 degrees to allow for roll, yaw, and small errors in course. Fired a 390-pound projectile. I won't go into the technical details, but those projectiles sank faster than the Hedgehog projectiles, and this is critical because you want to get to the U-boat as fast as possible because it's manoeuvring to get away. Pattern was a triangle with 120-foot sides. Could be tilted to the horizontal for loading, so you reloaded it, horizontally. Sea trials in late May 1943. Now, Squid's great advantage was that the depth setting on the bombs was set and continually updated by the new sonar. So it kept telling the bombs what the depth of the U-boat was. Now, it was developed in parallel to the Q attachment, which was, I won't go into here, but was an earlier depth finding system. But the 147B was a much more elaborate device. It carried a sword ahead of the main dome. It would normally pick up the U-boat at about 800 to 1,000 yards, so that's a shorter range than the main sonar. Continuously updated the depth setting on the Squid bombs. First trials about the same time, May 1943. First operational set in Hadley Castle, which was the first Castle class corvette. That's more or less how it worked. You found the U-boat with your Type 144, and then when it gets close enough, you can play around with the 147B because it's slaved with it, scan it horizontally and it'll tell you what the depth is. There's actually a destroyer steaming through the pattern of squid bombs that it's fired 200 yards previously. Now, the errors associated with the human element largely eliminated. The order was given it to steer by Asdic. So in fact, the helmsman would have a repeater in front of him and the captain would stop giving him orders. He would just steer to the Asdic. The captain's bearing instrument also showed the Asdic oscillator bearing in the ship's head, and the squid was fired automatically. So the captain didn't even say fire. He steered by the Asdic and then it went boom at the appropriate time. That's basically what it looked like. It would fire and the bombs would bracket the U-boat and the concussion would destroy it if everything worked. Now, lock class frigates. Now, as the foreseeable future, because we're talking about 1943 here, indicated unrelenting demand for even more escort vessels, they decided that what they needed was prefabricated construction. The lock class planned on mass production methods, and as soon as plans were finalised, no further river class were ordered, and construction switched to the lock class. They looked very similar and had a very similar hull form. They were a little bigger than a river class. Same machinery again, same speed. 2 squids compared with 1 on a castle class. You can see the 2 squids forward of the bridge there. Twin screws, similar propulsion system to the river class. Once it's still got the triple expansion reciprocating engine, so commercial yards can still build them. No fire control system, Type 271 radar, HFDF. It's got the Type 144 and the Type 147B sonar. Limited depth charges, but 2 squid mortars and 120 projectiles, 300,000 pounds apiece, but still cheaper than a Black Swan. Lock Farter was commissioned 14th April 1944. Prefabrication. A longitudinal scheme of framing was adopted with deep transverse frames about 5 feet apart and was proposed by Mr. J.L. Adams, CBE Chief Surveyor of the British Corporation. Who's heard of the British Corporation? Well, the British Corporation was one of 3 classification societies in Britain at the time in World War II. We've only got 1 left, haven't we? So there were 3, and the British Corporation was one of the 3. So a classification society did this. About 80% of the hull structure was prefabricated. They're going. Welding or riveted connections were adopted for manufacture of the units as best suited the resource of the unit fabricators. So some fabricators could weld and some couldn't, so they riveted, and it didn't make much difference. Now, to simplify things, because I should say that a hell of a lot of this prefabrication of these sections was done by non-shipbuilders. So they simplified it as much as they could. They replaced curved by straight lines wherever they could. And the whole form was revised in detail, especially above the waterline, because they figured above the waterline doesn't matter that much. The waterlines forward were run as straight lines instead of slightly hollow. Straight portions of considerable length were worked into the forward transverse sections, and the deck shear was run in 3 straight portions instead of the usual continuous curve. It's funny, isn't it? Old style ships, they would just have a nice curvy deck. Model tank experiments at Haslar showed that the revisions produced little or no adverse effect on resistance. That's a good result. In arranging the division of the structure to units, it was obviously necessary to have some limits because everybody had to be able to do it. And they didn't have the big cranes we have today. In fact, the weight of units had to be limited to 2.5 tons. Small potatoes by today's standards. The maximum dimensions could be 29 feet long by 8 foot 6 inches wide and 8 foot 6 inches high, and that was to suit transport by rail and barge. They had to move them about the country. Riveting was mostly adopted to connect the units together on the shipbuilding version with the shell plating. So often they would be getting a welded unit, but riveting it into the ship because that was easy. Now there's Lockfarter on the slipway on the 16th of June 1943, with some of those units being put into place. It's a bit hard to tell what they're doing, really. There she is on the 14th of July 1943, getting even more units put in place. So each of those panels would have been produced somewhere else, shipped in, attached to the ship. Then on the 15th of September 1943, and then the 10th of November 1943, coming together quite nicely. Now, compared with a River-class frigate, had a very similar hull form and dimensions. In fact, the only real difference was displaced 36% more and had a deeper draft. Not surprisingly, you can't get one without the other. Consequently, there was a small improvement in seakeeping performance, mostly due to the fact that it's a bigger ship. The locks did carry 55% more fuel than the Rivers, 730 tonnes compared to 470 tonnes, which is most of the extra weight. Double squid attack. Identical to the single squid attack, except you got two of them. Except that they fired all 6 bombs in a single salvo. It's a bit hard to describe this, but they had alternate triangular spread. So the broad axis was over the pointy bit of one, and pointy bit was, and they set the 2 triangles, one to be 25 feet above the U-boat and one to be 25 feet below the U-boat. The idea being that they would bracket it for the maximum damage, and that the resulting pressure wave would crush the hull of the U-boat. And that's sort of what it looked like. A bit hard to draw a 3-dimensional picture in 2D, but that's what was supposed to happen if it all worked. Once again, there's no blind period because it fires 200 yards in front of the U-boat. You haven't lost sight of it. Here's a testimonial. Do we know who David K. Brown is? He's a naval architect. He wrote a lot of books on warships in World War II, one of which was Atlantic Escorts, Ships, Weapons and Tactics in World War II, which I may have read. Now, he spent his entire civilian working career with the Royal Corps of Naval Constructors, retiring as Deputy Chief Naval Architect in 1988. On a personal note, I first became acquainted with the capability of the locks while serving in the unmodernised submarine Tabard in a big exercise with British and US ships off Gibraltar. This is after the war, I should say. We had no difficulty evading any escort group until we met the locks, who had us very quickly. Soon after, I transferred to Lockmore, so we transferred from a submarine to one of these lock-class ships, and learned how easy they found it to dispose of a World War II submarine. They could have coped with the Type 21 U-boat, albeit with difficulty, probably, or a Soviet whiskey class. After an earlier spell living aft in Chivalrous is a C-class destroyer, war emergency destroyer, covered access between the fore and after parts of the ship was welcome. And I swore that any ships for which I was responsible would be so designed. He ended up in a position to do that, didn't he? In my opinion, the locks are one of the all-time great designs. So how did it all work out? This is statistics now. Some of it's interesting. There were 5,174 depth charge attacks on U-boats, and which resulted in 85.5 kills, which is 1.65 kills per depth charge attack. Well, I mean, percentage. A small percentage. So we can see there that using depth charges, you had to use a hell of a lot of depth charges to sink a U-boat. Hedgehog, 268 attacks and 47 kills. So every 17.5% of the time, you destroyed a U-boat. That's a significant improvement, 10 times, isn't it? Single squid, these figures don't make a lot of sense. It's probably because there weren't a lot of single squid attacks. According to this, it's not very good. But then you look at the double squid, 27 attacks for 11 kills. 40.7% of the time, they were destroying the U-boat. The U-boats aren't going to survive very long with that sort of percentage kill rate, which was true, of course, at the time. Coming to the end now. This is an advertisement. I hope you're all aware that all RINA members can request 4 free papers from the RINA archives per year. And you could request that one, which of course I did, didn't I? Corvettes and Frigates by A.W. Watson. And if you do that, you'll find I haven't been lying to you, I hope.